is it wants a component attached to our ship 1 prefab called Photon View, which if you've installed the Photon Unity networking stuff, will show up under miscellaneous, Photon View. So we've added that there, and Photon View is responsible for synchronizing things across the network. Now, it will observe a component, and it will prompt that component. It will ask the component, hey, I need to do a sync across the network. Do you have any data for me? And the component will give them that data. And then vice versa, whenever the Photon View receives data over the network, it will feed it back to the component and say, here, these changes have happened. Now, you can put a script in here. For now, we're just going to feed it a transform. We're just going to give the ship's transform to the Photon View, and that should be sufficient to get rid of our errors, unless I've run into some more, and I have. No, I haven't. Here's my ship. Oh, because it's there. My camera is not looking at where my ship is. So this is the game view. But if I look at the scene view, indeed, it has spawned a ship. And it will also maintain the ship's transform, the position and rotation. You can also have it send just one or everything, including the scale, but the default is position and rotation, which is probably going to be all you need 99% of the time. It will keep that synced across the network. So that's good. I could test it now, but I want to make sure that things are wired in at this point. So we're going to go back into, I have to open my editor again because everything got closed when I was resolving that one issue. So we're going to go back into our network manager. And the reason that we didn't see our ship when it spawned in is because the camera was pointing off to some empty area space. So we have to tell our main camera, which has my camera script on it, we have to tell it what the target should be. We're going to have to do the same thing for the GUI, the user interface, so that it knows which ship is supposed to be our ship. So with the camera, there's a couple of different ways we could grab this camera. We're going to take the easiest route because there's only the one right now. So we can do camera.main.get component, and it's called camera, what is it called? Camera script. Now I have it open here. Camera script. So we're going to get this component, and we can tell it that the target is my ship, and it wants to transform. So we're going to tell it that. So the next thing we need to do is for the console, the navigation console, we're going to tell it where our ship movement script is, which is what it cares about. And that script is attached to our ship. All ships will have it. So the way I have the nav console set up is I set it up so that it would have a static instance of it. It kind of runs as a singleton, basically. So I can just do this without finding, without doing a get main or anything like that. I can just say navconsole.instance.ship movement is equal to my ship.get component ship movement, like so. And that, I believe, should get us back to where we were at the start of this demo. Let's find out. As soon as it joins, it spawns the ship. Our camera gets there, and we should be able to steer around and move. And at this point, this is even being sent out over the network. So let's give that a try. I will go to File, Build Settings, yes, PC, yes, Build and Run. Let's create a folder for Build. We're going to call this Spaceship Game. We're going to save that. Let's get this running. I didn't add the scene, but by default it uses the current scene. So we're there. Let's hit play. And it should do the same thing. Everything should work fine here. We should get our little debug information at the top. And we should get a ship. And we do. And I can move the ship around. And that's great. Now, when I go back over here and close that and play it in my editor, or double click the exe a second time, we should join here. And you can see there's two ships. Let me move ahead a little bit. Undock myself, and then turn around. There we are. And then I can go back over here, and if I move this to my second monitor, let me double check how XSplit is looking. I think you guys should be able to see me turn around. Now it's a little jerky because this has got to go out to the internet and back every time. So there's a slight delay between the very smooth motion on my left screen and the slightly jerky motion that you are seeing in the editor window itself, because that slight delay in updating the position. Now, we could pretty easily add in some movement smoothing here, and we'll probably look at that, I guess, now. Sure, why not? Anyway, that works great. Now, if you run into a problem where you are making a game, maybe you've got a first-person shooter or a third-person shooter, something like that, and you start moving your character around and it's moving all the characters simultaneously, it's probably because your prefab, your character prefab, like my ship here, it probably because you have your input handlers, your mouse and keyboard and whatnot handlers on the object itself, and when you have multiple players in the game, well, you have multiple copies of those objects, and they're all listening to the input, which is why you have to, in your network connection script here, when you spawn your player, that's also when you have to wire up all the inputs. The alternative is you could do something weird, like in your input script, you know, at the top of it here, you could have a little check to see, is the object that I'm currently on, does it belong to the player who's currently running this client? If so, then we can go ahead and proceed with, you know, reading his movement. Otherwise, no, let's back out, because we're not supposed to be handling movement from the keyboard. We're waiting for network input or something to that effect. So I mean, we're in pretty good shape here. Now, for movement smoothing, we can't, there's a limit to what we can do. I guess I can close off this client here. There's a limit to what we can do just by feeding the transform directly in here. This is the cheap and easy way to do it, but in practice what you want to do is you want to feed it a script, because then your script can A, feed more information back and forth than just the position and rotation, for example, but it can also use a little bit more logic to try to smooth out the motion. For some games that's going to mean movement prediction, and for other games that might actually mean almost a movement post-diction, where you take the last position that we got, and you take the position we currently have, and then you move the object around from those two positions using a slight delay. So technically, what you're seeing is slightly behind real time, but it will be very, very smooth. The problem with predictive movement is that if there is slight lag, what you can get is rubber banding, where you've predicted that some guy has moved this way because your client was like, well, he was moving this direction last frame, so he's probably still moving this direction. But then it turns out the person has turned. What you'll get is this sort of like bounce from one position to another as the servers sync back up again. Depending on what kind of game you're playing, one system may be better than another. Modern like first-person shooters that rely a lot on networking have very sophisticated systems to try to come out with the perfect medium of keeping everything balanced. Because part of the problem is you can't trust what you get from people's clients, right? What you could do is like, well, I'm shooting at where I see this person and the bullet hit them, so even if I'm lagged and they're not really there anymore, I'm still going to send the message that says that I shot this guy, right? And that's fair, and that ensures that no matter what, like, you know, the player doing the shooting is always, he doesn't have to like aim slightly ahead or slightly behind someone to account for lag. He can just aim where he sees the actual person being, and that works. But to a certain extent there, what you're doing is you're trusting the client to not cheat, because then if you're trusting that the client says, hey, I totally shot that guy, so give me a point, well, what's to stop the client from, you know, what's to stop someone from hacking their client to send messages that said, oh, I totally shot that guy, even though I really didn't. And that's, you know, that's well beyond the scope of this. I guess the key is to not make your game popular enough that people want to cheat. There you go. All right. So what we're going to do here is we're going to replace the transform here with, I'm going to use the ship movement script. It's already responsible for managing the ship movement. So adding on the responsibility of also sending that information over the network seems to make great sense to me. So my ship movement script is here. And is this the one that keeps sending out a bunch of warnings? I think it might be. Apparently it's not. Maybe those were from before. Okay. No, you know, I bet you some things aren't getting used here. So this script is actually a little bit of a mess. So if you guys are looking at this later on, I apologize for that. And part of the reason is I messed with a bunch of different ways of implementing the ship movement. I had true Newtonian movement for a while, which is how it works in space. You know, you give yourself a burst of speed, and then even though you've stopped all your engines, you're going to keep coasting in that direction. I messed around, you know, and the ability to, even though you're coasting one direction, you could rotate your ship around and face the other way without changing your movement. So you could literally be like moving butt forward through space and then shooting people who are trying to chase you. And those are all valid ways of doing it. Ultimately, I ended up going with this sort of very, I don't know, non-Newtonian, very atmospheric style of flight, because it feels good. A lot of games end up doing it, these space games. It's not hard to make it realistic. It just turns out that it's kind of a pain in the ass to play that way. It's not always fun. So I don't know. It's very easy to switch back and forth, and I might do it 30 different times if I continue to develop this game. But for now, that's fine. So everything still works great on my end, but because I have broken the what am I calling it? The movement view. The words. I need words. The photon view, because it's no longer linked to the transform. It's currently querying the ship movement script for network data, and the ship movement script isn't sending any. Therefore, no one would see each other move anymore. You can still move yourself just fine, but you can't move anyone else. You can't see anyone else move. So we're going to resolve that, and the way we resolve that is by using on Photon serialized view. This is a little bit wordy. We'll put it down here. So, is it here? I'm just trying to think. Just trying to think if we have to change the mono behavior or not. I don't think we do. We'll see how it goes. On, what am I saying? Photon serialize view. And, oh, it passes a stream, does it not? Yeah, and let me double check the documentation on this. I guess that would be in the thing. You know what? Let's just give it a try and see what happens. It would be in the PDF. Here we go. Should be able to open this up. I just have to double check exactly what it's supposed to look like. Oh, you know what? Here we go. I finally found it in my web browser. Let me do a quick copy and paste. Boom, 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 boom. Like I said, I haven't done a whole lot of the multiplayer before, and by not a whole lot, I mean none. I've done none. So this is all pretty new to me still. But there we go. So on Photon serialized view gets past a couple of objects, and this is blinking at me, so let's get rid of that. Okay. Most importantly, we get the stream, and what we can do is we can find out if we're reading or writing. Right? If we're writing, then we are sending data to the network. Otherwise, we are receiving data from the network. Right? So what are we going to send back and forth? And that's kind of interesting. That is very interesting. I guess we are going to use some movement prediction, because ship movement expects to know what the velocity is, right? It knows the velocity. It knows how quickly we're turning. And it can also check up on the object's transform to know where we actually are and what our actual facing is. So what we're going to definitely do is we're definitely going to send our current position, right? We're going to go stream.send next, and we're going to send our transform.position. And we're going to do the same thing with our transform.rotation. We're going to send both those things, and we will. We also have to deal with receiving them. So if we're on the receiving end, then we are going to say transform.position. We're going to set it to stream.receiveNext. But stream.receiveNext returns a generic object. We've got to cast it, and we know what objects are coming in what order. So because they all get queued up. So we can say we know the next thing is a vector, and it represents the position. And then after that, we are also going to be getting a quaternion, which is our rotation. because that's what we're doing. Now, if I ran this like this, we're going to see if this works or not. We're going to find out. Yeah, see, there we go. We do have mass factor, which I'm not using because I'm not using Newtonian physics. I don't use drag. I'm just going to comment them out for now. And maximum velocity is also not used. Right, that's very true. See, this code is, you know, it's whatever. Needs to be, it can be cleaned up, and in fact I probably will clean it up and strip a lot of this stuff out and just put what's actually supposed to be here when I actually put it online. So if I run this, and we can move, and that's fine, then if I go and build and run, I think we're going to be where we were before. Play here. Good, we're going to get ourselves drifting forward ever so slowly, and then we're going to go over here, and we should see someone drifting away from us very, very slowly. Perfect. Now, it's still ever so slightly jerky. It's not as visible here. If I just throw in a bunch of rotation, though, I think then it'll be... Yeah, see, there's just... I don't know how much this is showing up on YouTube, but it's definitely not smooth. And the reason is, in this client here, in my editor, this ship, the velocity and rotation, or rather, the velocity and turn rate of this ship is 0. So in between updates, which happen X number of times per second, in between updates, this ship doesn't move at all. So that's why you get this sort of jerkiness. But what we can do is, and we'll have to close this, is we can go here and we can also send it what our turn rate and velocity is. Turn rate, actually probably do it this way. Velocity and also the thrust, since the way I have this put together, the an impulse actual, and there's so many things wrong with this. I guess I could send it all these. It'll actually be even more accurate if I also send it the impulse and the impulse actual. And of course, if I actually program this to be halfway decent, then I would probably not have to send as much. But let's send everything. Now, this is actually going to lead to more networking overhead, but I just want to do it this way so that, I guess we'll do it like this, so that we get something hopefully super duper smooth. Since we only have 2 players, the overhead doesn't really matter. Now these should all be, I think, vector 3s. Indeed so. So now not only are we sending the current position, we are also going to send the current speed. Oh, that did stop it from playing. Okay. I have to play it on my client here first. Play. Okay, and then play here. Now no one should be moving. And they should actually be one on top of another. So if I start this guy moving, looks pretty good. If I stop moving, stops there pretty good. And then if I get him rotating around both directions, it looks really smooth here. Every now and then again, there's a little bit of a twitch, but it's pretty much non-existent. In fact, I may just be imagining it. It may be a recording things. It's really, really, really smooth. And if I stop all the rotation and give him some speed, yeah, there's a little bit of back and forth. But that could be eliminated even further if instead of taking things directly, you were using like a lerp on the rotation and position and all this, because what we should be doing is probably taking into account a little bit of the time that's passed and trying to do everything we can to smooth things out. And again, we don't need to pass all this many things. That was just me being a little bit ridiculous, but it's pretty damn close at this point. In fact, it's probably as close as you're going to get in any real world game as well. There's always going to be a little bit of jerkiness as people move around, and it adjusts it, you know, until people are standing still or whatever. this also guarantees pretty high fidelity. That's the thing. If we're willing to give away more of the fidelity, and that's what things like using a lerp, for example, will do. Lerp will gradually move from one position to another, will smoothly move from one to the other. Technically, doesn't have high fidelity. It doesn't represent necessarily what the other player is doing. It just makes it look good. But the thing is, looking good is 99% of what it is, because the small differences here aren't meaningful. But right now, we're just going to leave it as that. And I'm going to take a break. But that's basic multiplayer right there. We can have up to 20 people in this game moving around. They can't do anything with one another. There's no shooting in the game yet. But it's there. And everything is about more of these states. What we're going to look at next time is we're going to look at RPCs, which allows us to send function calls across the network. And that's going to be very important for doing more significant things, like shooting and dying and sending status reports. Maybe the status reports are mostly going to go in here. But there's other things we can do with RPCs that we won't send this way. This is to keep the state updated. So really what we've looked at is two things right now. We have looked at how you create a new object in the game, and we have looked at how to keep those objects synchronized. But this is just for states synchronization. When you actually want to do something, you're going to use a remote procedure call to send that information back and forth, like tell someone, hey, I shot you. So yeah, I will see you guys next time. Bye-bye.